Hello, first of all, I want to thank you very much for taking your time to watch my video on my research experience. We present on the role of eosinophil-mediated immune response markers in detecting hookworm infection. My name is Ebenezer Senu. Currently, I'm a research assistant and data scientist at Dr. Siti's lab, Department of Molecular Medicine, K University here in Ghana. This is the outline of my presentation. So hookworm is a major public health concern in Africa. Previous study published in Nature shows that Ghana has a prevalence of around 10%. Most often humans are infected through contact with the testate filariform larvae, which penetrate through the skin and are carried through the vein to the heart, lungs, and finally to the small intestine where they reside and mature into adults. For the past year, diagnosis of hookworm infection has been based on the detection of the egg stage using wet mouth microscopy, where we are able to see the oval-shaped egg under the microscope. However, this wet mouth microscopy only detects the egg stage and is subjective and is less sensitive. During my 3-month internship at the University Hospital here in Ghana, I found that 90% of hookworm positive subjects presented to the facility has eosinophilia, showing that eosinophilia was mediating pathogenesis of hookworm infection. So I therefore joined Dr. Siti's lab to see if this eosinophil-mediated immune response markers could be used as a diagnosis marker. But previous evidence shows that in hookworm infection, there's production of CCL11, which is a chemotactic protein that is involved in recruitment of eosinophil. And when the eosinophil is recruited, the secretion of eosinophil cationic protein from the matrix of the eosinophil. And this ECP possesses a hematotoxic activity, which is involved in the RNA cytotoxicity of the hookworm infection. Also, hookworm infection leads to production of antiparasitic immunoglobuline B. Previous studies by Dr. Eta assess the role of T2 response and parasite products in eosinophil recruitment during other helminth infection using a mouse model. In their study, they found that in Tinea spiralis, after 12 days post-infection, eosinophil count decline. Also, they also find that in Tinea morvis, after 20 days post-infection, eosinophil levels start to decline. So, despite the evidence of eosinophil-mediated immune responses, the usefulness of the eosinophil-mediated immune response markers for detecting hookworm infection has not been well explored. The diagnosis has been relied on conventional wet mouth microscopy, which sometimes leads to misdiagnosis. So I therefore hypothesize that eosinophil-mediated immune response markers could be used for detecting hookworm infection. So in my study, I used unmatched case control study where I recruited 40 hookworm positive subjects and 36 apparently healthy controls. I took 2 samples for the hookworm detection using the Katoka techniques, and I further this speciation using PCR. So most often, the most common species of this hookworm in Africa is the Asilotoma dudoni and Nicata americanus. So in my study, all my species isolated was the Nicata americanus. I also took venous blood samples, and I used part for serum markers quantification using sandwich analyzer, and also part for eosinophil count levels measurement using the ABS Spectra 60X 60C plus hematology analyzer. My laboratory result of my data was managed in R language for statistical computing, where I used kernel density and Valin plot for look at the distribution of my biomarkers between the 2 groups, that's hookworm positive and hookworm negative. And also I realized that my markers were non-parametric or not normally distributed. So I compared their level using them with UTEX. And also I tried to look at how these markers correlate or predict the hookworm infection intensity using a multiple linear regression model. And finally, I used the receiver operator characteristics to see how these markers able to detect the hookworm infection. So this is the density plot showing the distribution of my markers, and down here is the value plot being completed with the box plot. So I found that eosinophil levels, although were higher in hookworm positive subjects compared to the hookworm negative, they were not statistically different. This could be attributed to the fact that eosinophil is an innate immune response marker, and also eosinophil has a shorter half-life of 2 to 5 weeks, showing that hookworm positive subjects who have had the infection for a long time or in the chronic stage will have their eosinophil levels start decline back to normal, as also shown by the ERDSI in that study in the mouse model, who shows that after some days post-infection, the mouse model, the eosinophil levels start to decline. However, I found that CCL11 and ECP levels were significantly higher in the hookworm positive subjects compared to the hookworm negative subjects, showing that these immune response markers were mediating the pathogenesis of the hookworm infection. So I further do the multiple linear regression models to show how these markers predict the intensity of hookworm infection. I found that CCL11 was strongly negatively correlated with hookworm infection intensity, and a unit increase in CCL11 level was significantly associated with 0.81 decrease in hookworm infection intensity. Also, eosinophil count was moderately positive correlated with hookworm infection intensity, and a unit increase in eosinophil count levels was associated with 0.62 increase in hookworm infection intensity. Although ECP correlated positive with hookworm infection intensity and IgE correlated negative with hookworm infection intensity, they were not significantly associated with hookworm infection intensity, showing that CCL11 and eosinophil can better predict the intensity of the hookworm infection. I further did the ROC diagnosis test to see how these markers perform in detecting hookworm infection. I found that ECP was the best performing biomarker with a very high area under curve of 97.0%. And further analysis showed that at a cutoff of 39.05, ECP was the best diagnostic marker with high sensitivity of 97.2% and 87.8%. In conclusion, ECP best predicts eosinophil-mediated immune response markers for detection of hookworm infection with high sensitivity and specificity. However, CCL11 and eosinophil can better predict the intensity of hookworm infection. So further study direction of my findings shows that ECP can be used to develop an affordable, high-sensitive antigen antibody-based assay for the detection of hookworm infection. Also, I can utilize molecular biology and genetic knockout techniques such as the deletion of RNA storage gene, which code for ECP, and perform bulk RNA sequences on eosinophil to see transcriptional changes that may be of therapeutic target, not only for hookworm infection, but other Th2 responses such as asthma and allergy. Since this hookworm infection being a parasite, the responses were as a result of Th2 responses. These are my references. I want to acknowledge my lab. So the impact and presentation is that I presented my data at the Kumasi Center for the Collaborative Research in Tropical Medicine here in Ghana, where I met other scientists, and a lot of them were interested in my work and engaged in insightful presentations. My study findings also be published in the Health Science Report. Also, I want to acknowledge my lab members, Dr. Samasichi is my PI, research scientist in our lab, current graduate and undergraduate students, also past members of the lab who are currently doing their PhD in US and in Germany. Thank you very much for taking your time to watch my video on my research experience. Thank you.